Okay, in today's video, we are going to be going over three things. First, writing a function rule for, and then evaluating and then solving that model that you write the function rule for of a linear function. This is the meat of the matter for portfolio test number 3. So pay attention. Okay, write a function rule for this contextual situation. A monthly cell phone plan costs $30 for unlimited calling plus 15 cents per text message. So in the last class, we went over identifying independent and dependent variable. So in this case, because we can say that the total text messages depends, the total charge of my cell phone bill depends on how many text messages I send. The total charge is the dependent variable, and the total text messages is my independent variable. So this is part of defining your variables. The other part of defining your variables is actually writing what variable you're going to use to represent the independent variable, and then the function notation you're going to use to represent the dependent variable. So in this case, we're talking about T for text. I think T makes sense to use, so I'm going to go with T here for total text messages. So that's defining my variable. I'm using T to represent a variable, which represents the amount of text messages that are sent. Okay, my dependent variable. So that is my total charge, and I need this in function notation. I'm going to use the same letter that I used to represent the independent variable, but my representation in the equation for dependent variable is f of t. So we went over function notation in the first lesson from this unit when we evaluated functions. This whole process here is called defining your variables. So identifying the letter that you're using to represent the variable, t, what it represents in the problem, the total text messages, and then same for the dependent variable, f of t, total charge in the cell phone bill. Okay, now we need to come up with a function rule. The easiest way to identify a function rule is usually in the problem you're given some numbers, right? A 30. A 0.15 in this case. Those numbers represent two things when you're dealing with the type of model that we're going to work with in the portfolio tests and also today and in a future lesson as well before the portfolio test, and that is a linear model in slope-intercept form. So in slope-intercept form, on the right-hand side of the equation, there's a slope and a y-intercept. Well, in the context of a problem, that is called our initial value, which in this case is $30. It's where you start from in the problem. In this case, the cell phone plan is costing $30 to begin with. Whether you send 0 text or 1,000,000 text, you're paying $30 up front no matter what. And then the other number in the problem, after the initial value representing the y value of the y-intercept, is my rate of change. That is what I'm multiplying the independent by the independent variable, in order to cause the change in the problem. For every text message you send, you add another 15 cents, add another 15 cents. So we're going to talk about the rate of change in context in the next lesson. But these are the two numerical values in the problem. They represent the slope and the y-intercept. And then if you know the independent and dependent variable, you just drop them in their places. The y, left-hand side of slope-intercept form, you just put in the dependent variable representation, f of t. And then independent variable, that in the same way you have an x in slope-intercept form, your rate of change gets multiplied by your independent variable. So this is my full equation. F of t is equal to 0.15t plus 30. Okay, so let's just bring this into context as well for slope-intercept form. So that means that this is our function rule. It can also be written in slope-intercept form, y equals mx plus b. See, y is equal to 0.15x plus 30. You can use this for graphing. If you want to think about graphing being an equation, an x and y, you can graph a function that's in this function rule notation as well too. Okay, now we're going to do things with this function rule. We create a function rule not to just put it in space, use it to predict outcomes of either the independent or dependent variable. So here we're given a part of the contextual situation as well. Using the function rule you created, but with the total charge of the cell phone bill if you sent 1,100 text messages. Well, here's the question you want to ask yourself. Is the number given in the question a value of the independent variable or a value of the dependent variable? The number here is 1100. So what is that? Text messages. Okay, that's the independent variable. So when you are given an independent variable, you're using the same function rule from the last slide, right? And you're substituting and evaluating. Same thing as lesson 3.1 that we learned. You're evaluating for a value of the independent variable 1100, substituting that 1100 in for t in this top equation, and then just evaluating the right-hand side of this numerically. 0.5 times 1100, that's 165. Bring down the 30. 165 plus 30 is 195. You write it using this notation. This is for a value of the independent variable 1100. You have 195. Now you have to put that in context. That means for 1100 text messages, you're answering the question, the cost is $195. So once again, this is evaluating. This is called evaluating the function. I know it's evaluating because I was given a value of the independent variable. Okay, you probably know what's coming up next. Here, you receive a bill in the mail for your cell phone company for $213.75. How many texts did you send the month prior? Same question. Is this a value of the independent variable or dependent variable? Well, we did independent already. Clearly, this is dependent. And that makes sense. Dependent is the total charge. So use the same function here. Whoops. Use the same function here, except you're substituting for $213.75 for f of t. So we're same function, but instead of substituting for t on the right-hand side, we substitute for f of t on the left-hand side, and then solve this equation algebraically for t. This is something, even though there's decimal representations here, we should, in the scope of this class, be able to do, right? Using our properties of equality, using our solution steps for solving a linear equation. So that's just subtract 30 from both sides. That eliminates this 30 on the right. You bring down the 0.15t. 213.75 minus 30 is 183.75. Divide both sides by the coefficient to t, 0.15. It's okay that it's a decimal. That's all right. You know, these still divide to 1, right? And these subtracted to 0. So these still divide to 1, and then you get your outcome. T is 1225. Or you can write it with t, usually the variable on the left-hand side is how you see it. So once again, put this problem in context. 1225 floating in space, what does that mean? You're answering this question. How many texts did you send the month prior? 1,225 text messages. So this is called solving, right? When you substitute for a dependent variable and you're using algebraic solution methods, you're solving, you're not evaluating. Okay, so just to put this in context of a different representation and bring it back to a topic that we've done so far, potentially also from topic 3.1. Remember, you can graph this function. I decided my scale along y, my dependent variable, was my total charge of my cell phone bill. And remember that y, I wrote y there for really just the y-axis, but this is f of t along y. Right? And along x, total text messages, that's t. So my scale along t, I went by 100s. I did that using methods we talked about in the previous video. I just evaluated at 100, and I decided that it would be easy to go by 100s, going up 1 over 1 on the grid. My y-axis, I decided to go by 15s. Because that made it easy to show the y-intercept of 30, and also it shows other values of the graph. So y-intercept is 30. This is my graph. There's also a coordinate point here, right? Because if I substitute 100 in, this coordinate point right over here, that is 100 plus, or sorry, 150. Sorry, 15 plus 30, 0.5 times 100 is 15, plus 30 is 45. So this is the coordinate point 100, 45. 100, excuse my drawing of 100, and then comma 45. So this is a different representation. Remember that in this portfolio test, I'm going to be asking you to graph the function that we're going to be working with. Okay, so that concludes our notes on writing a function rule, and then evaluating and solving.